now we're going to look at solving quadratic equations. I have a general form of a quadratic equation written here. Ax squared plus bx plus c equals 0. The first thing we've talked about is if you can factor these things, you always want to look for factoring first. But you don't have to spend too much time if you're stuck. There's other options to be able to solve these. Now, most things do not factor, so factoring is not going to solve a lot of the problems that we look at. So one method that can be used is something called completing the square. Now, the steps for completing the square are as this is. Steps will be make a equal 1, so you need a to be 1, leading coefficient. If it's not, you're going to make it 1. Variable terms, get those on the left, constants on the right, and then you complete the square. So what you do is you add 1/2 of what b is, and you squared the square of 1/2 b. You add that to both sides. What you're doing is making a perfect square trinomial on one side, so it factors to the square of a binomial. And then you factor this thing, and then once you factor it, you just use the square root property, because then you'll have something squared equals a constant, so you can solve it. So it's basically breaking this into a form using properties that we know are true. Whatever you do to one side, do the exact same thing to the other in equations in order to use the square root property to solve these. So I just want to show you and run through a few of these. My recommendation, though, I say if you're going to use completing the square, some people don't even use it at all when you run through this. You can get by with just using the quadratic formula. Coming up next, we'll be showing that. But I do say it's worthy of looking at and knowing, and I recommend using them only when you recognize a is 1 or can be made 1 quickly, and b is even. If it's not, you can end up with a fraction when you complete the square, and fractions, you do not want fractions. Fractions just make this, avoid fractions at all costs on these, and then that's what the formula is there for. So quadratic formula, so we'll be using that. But anyways, a problem like this, if somebody gave me this, I would definitely, instead of just solve it, I would definitely factor this. It's the fastest way possible, right? This becomes x minus 7 times x minus 1. And then I would set each factor equal to 0. I'm sorry, x minus 7 times x plus 1. So if somebody gave me this problem, this is how I would do it. Minus 7 plus 1, and then set each factor equals 0 and solve, and you should get x to equal 7 and x to equal negative 1. Really fast. That's why you want to know all methods. You want to be able to find the fastest way possible for solving these things. So it's really 7 and negative 1, or negative 1 and 7 are my two answers here. But this works for all quadratics. Any single quadratic, you could actually, even ones that don't factor, it works. You can find the answers to these. So let's look at this one. I can find and show you that it's going to work with the same thing. So I'll look at this, and I'm going to take the first step. It's already done. A is 1, so I have x squared minus 6x equals 7 by just adding 7 to both sides. Get the constant on one side, on the right side, your variable terms on the left. I left a little space because I'm going to complete the square and add that number here. I'm going to make this a perfect square trinomial. What I mean by that is I just take half of b and square it. It's always going to be a positive number. Well, half of that is 3. Squared is 9. I'm going to add 9 to both sides. You can go off to the side to show that. It's 1/2 times negative 6, and then I'm squaring that. You can even ignore the negative because when you square it, it becomes positive. But it's negative 3 squared, which is 9, and you always, I'm not breaking any properties. I'm adding 9 to both sides. I have not changed they're both equivalent equations. I've not changed the solutions to this yet. So now I want to factor that. You can factor normally if you want to, and you know it's going to be like x minus 3 times x minus 3, because what multiplies to be positive 9 adds to be negative 6. But you notice that there's going to be 2 of them every single time. When you make a perfect square trinomial, they become the same binomial twice, guaranteed every single time. That's why they're so special. So this really just becomes this. Now you can just skip to that step always. Once you get used to doing these, you look at this and go, what's being squared in the front goes in the front. This sign always goes here. What's being squared in the back goes in the back. But this will always be the case. That's why you made a perfect square trinomial. Now we're to, cool, something squared equals a constant. I can just use my square root property to solve this. Plus minus the right side, that wipes out. And so I get x minus 3 equals plus minus 4. Add 3 to both sides. I'm going to have x to equal 3 plus 4 and x to equal 3 3 minus 4, and so I should get those two solutions. We're kind of running out of space here, but I should end up getting x to equal, what, 7, and x to equal -1. That was this one. And there's my two solutions. So that's what we found by factoring. Factoring was way better, right, and way quicker. But this is still a really quick method, and actually I do recommend this over, I actually recommend this over the quadratic formula when A is 1 and B is even. It's actually a pretty quick way of solving these things because you'll get pretty fast at it and notice, oh yeah, half of that, so I'm adding 9 to both sides, and you'll jump to this quickly, versus the quadratic formula can be pretty precise and tricky sometimes, I mean, especially with the simplifying of it. So, that's why you always want to look for the easiest way on all this stuff, and you want to have as many tools as possible, and this is one. You can solve any of these, even if they do not factor. You can solve using using completing the square for quadratics. Now let's look at a trickier one. A is not 1, and it's like, oh wait a minute, it said not to use it. But I can make A 1 pretty quickly in this problem. If I go like this, and I could just divide 2 out into each side. That's what I'm going to do. I'm sorry, I wrote that first. I'm just going to divide by 2 to both sides because I have an even number all the way through here. So I should just end up with x squared minus 2x equals 9. It's an equivalent equation. I just divided by 2 to both sides. Now A is 1 really quickly. It's nice. I can complete the square of this, and we'll leave a little bit of space so we can do that. So half of -2 is -1 squared is 1. So you would add 1 to both sides. Now I'm going to end up with, this is just going to factor 2. Same sign goes here. What's being squared there, what's being squared there goes there. Or you could just factor normally, x minus 1 times x minus 1 is equal to 10. You're already down to here. I can go square root plus minus square root. This wipes out. I have x minus 1 equals plus minus square root of 10. That's not going to break down anymore, so it's just 5 times 2. So I would just add 1 to both sides in front of my plus minus, and I'll get 1 plus or minus the square root of 10. So I didn't show how I got that 1. I mean, writing, I talked it through, but basically this is always, completing the square is always 1/2 of b, so it's 1/2 of -2, and then you square that answer. So 1/2 of 2 or -2 is -1. Square it, you get 1. So that's what you add to both sides. You can show that off to the side. You don't even have to show that because, I mean, after a while you get really quick at that. So it's a really nice way versus this problem right here would not have factored. I would not have been able to solve this by factoring because I didn't have a perfect square factor or Vatican underneath it. But it worked out nicely using completing the square and pretty quickly. So that is using completing the square. Now, if I ever made this an odd number, if you take half of that, you're forcing a fraction already, and then you square it, you get a fraction. It's just a mess, and so I recommend just avoiding it. Don't use it, and that's why they came up with the quadratic formula. Now we're going to show next a video where showing how they derive the quadratic formula just by completing the square of this standard form, and I'll have a little video if you're interested in seeing that. I won't require you ever derive it, but it's nice to see where it's coming from. And then you can use the quadratic formula also for all these problems, and it works fine. And you have choice, actually. I always test where I give you a choice on those. I don't force you to use one method or the other. So, all right, that's it.